Hello, I am David W. Parker. This is Programming Today I Learned 3D Graphics Series Part 5, looking at vectors again. Today we'll be looking at cross product, and let's go ahead and get started. Cross product is also a multiplication between vector and vector. It's known as the outer product as well. So 3D vectors only using cross product. And we're going to go ahead and yield a vector, and it's not commutative, so meaning A cross B is not the same as B cross A. So what is it exactly? Here's the exact formula we'll be looking at. And as you can see in the top row here, what we're going to do is we're going to take the next element and multiply by the second element and then subtract the z1 times y2. And then on the y level, we're going to go ahead and take the next element, which is z, multiply by x2, and subtract the x1 times z2. And then finally, on the last one, we're going to go ahead and take the next element, x1, multiply by y2, and subtract y1 times x2. So here's an example of that. We have the different elements here, and the maths behind it, and here is the yielded vector. What it is going to do is it's going to yield a perpendicular vector to the original two vectors. So here's vector A, here's vector B, and here is A cross B. Its magnitude is equal to the product of the magnitudes of the original vectors and the sine of the angle between them. So the magnitude of A cross B is equal to magnitude of A times the magnitude of B times sine of theta. If A or B are parallel, or is the zero vector, then A cross B is 0. The zero vector is parallel to every other vector, and remembering that the zero vector is perpendicular for the dot product. So it's parallel for the cross product, and it is perpendicular for the dot product. Its direction, so you can see back here on this example, the direction could be up or down, looking at that example. It really depends on if you're left or right-handed coordinate system, which we will get to at a later time what those exactly mean. But we determine that by placing the tail of B onto the head of A. So if we have an arrow facing here, going up this direction towards the turn, and then another one here, you'll just project the tail of one into the head of the other. And then we determine whether we're drawing clockwise or counterclockwise from A to B. In a left-handed system, A cross B points towards you if it's going clockwise, meaning if the B angle is going clockwise from the head of A, and it's going away from you if it's counterclockwise. So if the tail of B is going counterclockwise, then it's going away from you. And for the right hand, it is going to be the exact opposite. So A cross B is going away from you if it's clockwise and towards you if it's counterclockwise. It's not commutative, so it's anti-commutative, in fact. So A cross B is actually equal to B cross A times 1. It's not associative. A cross A is going to always be the zero vector, and A dot A cross B is going to also be the zero vector. And you have to remember that because the dot product of a perpendicular is 0, and the cross product produces perpendicular vectors. So we're going to produce a perpendicular vector, and then the dot product between that is going to be 0 as well. We're going to use it a lot when we're trying to find anything that's perpendicular. So that's basically the main use for it. That's it for this episode. If you like what you saw, go ahead and give me a like, share, subscription, all the things. Go to ProgrammingTIL.com and sign up for my newsletter. And have a great one, and thank you so much.